This is our Sapphire Kingdom Gemology YouTube channel, and the lesson number is 77. That is Heated Sapphire Inclusions Part 6. We are learning here in this channel from here to upwards. We are learning the inclusions regarding the heated, natural, and synthetic inclusions. I need to show you how to identify the stone through the inclusions. You can think about the country also, origin also, not only natural, heated or synthetic or diffuse treated or anything, but also you can find the origin country also. So please take these screenshots, printouts, and write a note and learn more and more with the note. I upload twice a month. That means 2 weeks time I gave you to study well. So the next Saturday, we are uploading this and you better find out the inclusions. Now look at this cover photo, Sapphire Heated Inclusions, Part 6, lesson number 37. And this is some kind of inclusion in heated we can learn inside the lesson. Sharp angular growth zoning in yellow gemstones here. We are moving. This is ink spot internal diffusion. Ink spot internal diffusion. We can learn in next slides. Okay, we are moving. Sharp angular growth zoning is in heat-treated yellow gemstones from Sri Lanka. What is the lighting condition here? It is shadowing. Lighting condition is shadowing. Then we can see this kind of inclusion inside. Angular growth zoning. There are zoning in heated sapphire in Sri Lanka. Please subscribe and give a share to our youth because our youth need the knowledge. Some Tamil speaking and another language speaking people are there. They can't understand Sinhala. So I thought this channel will help them. So share to your all friends who need gemology with the sharp gemology, clear gemology knowledge. Now we are moving to next. What is this? Look at the picture here. Then you can see what you can see is the lighting condition here is oblique fiber optic. It is Sri Lanka sapphire. Look at the faceted sapphire and the inclusions inside, and look at these water drops like dots. You can see here all are glassy discoids. When the particles that are dissolved in Sri Lanka yellow gems are heat treated, magnesium escapes from the particles and creates yellow, producing trapped color centers. There are trapped color centers. We are teaching later after lesson 90. We are teaching that. So that trapped hole color centers are giving the color, escaping the magnesium. It gives yellow color to the stone. The result is concentration of color around the particles, a process that gemologist John Koivula calls it as internal diffusion. It is internal diffusion. So this is very important picture. We are moving. This one also. Light field, diffuse light field is the condition. When the particles that are dissolved in Sri Lankan yellow gems are heat treated, magnesium escapes from the particles and creates yellow color, producing trapped color centers. So the trapped color centers we are learning after the lesson 90 under the Geuder. The result is a concentration of color around the particles. All around the particles, the color given. A process that gemologist John Koivula calls it internal diffusion. This is called internal diffusion. This is heat-treated yellow sapphire, Sri Lanka. Now, what is this? The lighting condition here is short wave UV, ultraviolet short wave. Look at the stone with the faucet. It is Sri Lanka heated gem. Pink gemstone are usually heated at relatively low temperatures. That means below 200, 1200 Celsius to remove the blue color. Under this temperature, they are heated to remove the blue color from the red and blue stone. So we can remove the blue. The rarely alters the inclusion, which can often be revealed by exposure to short-wave ultraviolet fluorescence, which develops chalky zones as shown in stones. Look at this pink color stone. You can identify the chalky areas. It gives the evidence it is heated. So this pink is heated because of this ultraviolet color. Ultraviolet rays give the fluorescence of blue fluorescence. That is the evidence. Right. We are moving to next. What is this? Lighting condition here is ultraviolet short wave. This is also heated stone. Then what happens here? When low iron sapphires are heat treated, this inside this sapphire, iron is very low. So it is low iron sapphire are heat treated. A chalky short wave fluorescence often develops. It develops under UV light. It develops the chalky fluorescence because of low iron. This is usually associated with colorless or light colored areas of the gem and follows the crystal structure as seen here. This is strong evidence for heat treatment. Now you know the reason. We are moving to next. What is the color condition here? Lighting condition is light field plus oblique fiber optic. Fiber optic oblique plus light field. This is heated gem, Sri Lanka gem. What is written here? When rutile silk containing sapphire, such as this stone from Sri Lanka, is heated, the titanium from the rutile, these are the rutile, titanium from the rutile passes into the solid solution in the sapphire. Titanium passes inside the sapphire, coloring the surrounding areas of the rutile blue and creating a distinctive ink spot. You can see the ink spots here. Because of titanium, it creates the ink spots. Internal diffusion on pattern. So this is heated pattern. So this is, you can understand after lesson 90, lesson 92, lesson 104, all the 15 lessons are regarding the Gauda treating. It is coming in the future. Every 2 weeks, I upload the video. Then, if you forget to subscribe, please subscribe and share to your youth, your friends, relatives, everybody who can't understand Sinhala, because they can identify, they can learn from this lesson, this channel, Sapphire Kingdom Gemology. This is the English medium channel. Okay, we are moving next. This is lighting condition here also, light field plus fiber optic oblique. What is here? When rutile silk containing sapphire, inside the sapphire, rutile silk is there. So, such as this stone from Sri Lanka is heated, the titanium from the rutile in this area, from the rutile, titanium passes to the gemstone. When heating, it becomes a solution like. Then it passed through the stone. The titanium passed through the stone and create the ink spots. Internal diffusion pattern creates the ink spots. Now you can see the ink spots created here with the heat treating. Glassy discoid is here. And when rutile silk containing sapphire, such as this stone from Sri Lanka, is heated, the titanium from the rutile passes into the solid solution in the sapphire, coloring the surrounding area of the rutile blue and creates a distinctive ink spot, internal diffusion pattern. You can see the small ink spots here around area. So it is giving the evidence it is heated. What's it here? It is natural sapphire from Sri Lanka, but it is heat treated. Enhancement is heat treated. Lighting condition here is fiber optic oblique. What is given here? Fingerprints. This is very big fingerprints. Fingerprints are made up of tiny negative crystals. Tiny negative crystals made the fingerprint. These often contain carbon dioxide and are formed deep under high pressure. Inside here, inside these negative crystals, carbon dioxides, sometimes H2O, water, it is included there. By the time the gem reaches the surface, the pressure exerted outward can be quite large. Therefore, they are particularly sensitive to heat and often explode if the gem is heat treated. Especially H2O is there, that H2O explodes and giving the crack to the gem. CO2 is not like that. So the CO2 bubbles are not harmful, but the H2O bubbles are completely harmful to the stone. Here we can see what happens when such a fingerprint is subjected to heat treatment. So you can find it, what happens there. Each tiny negative crystal explodes. Each tiny negative crystal explodes, creating a series of microfractures. You can see very big area, big amount of microfractures inside the stone. So when see this, we can decide this is a heated stone. All are microfractures because of CO2 bubbles and H2O bubbles are inside these negative crystals. Those are explodes. Especially H2O bubbles are dangerously explodes. So that is the reason. We are moving. What is here? Natural sapphire, but heated. Enhancement is heated. Lighting condition here is fiber optic oblique. Then look at the internal picture. Many crystals have shallow cracks on their surface. See, many crystals have shallow cracks. In sapphires from Sri Lanka, Myanmar, and Madagascar, these cracks often flex, often contain yellow flecks. These cracks often contain yellow flecks. Heating to high temperature not only destroys the yellow flecks, but also begins a healing process, where, as we can see here, the cracks turn white and begin to form fingerprints. Cracks turn white and begin to form fingerprints, damaged fingerprints. Many crystals have shallow cracks on their surface. In sapphires from Sri Lanka, Myanmar, and Madagascar, these cracks often contain yellow flecks. Heating to high temperature not only destroys the yellow flecks, but also begins healing process, where, as we can see here, the cracks turn white and begin to form fingerprints, like here. So this is heated environment. We are moving to next. Lighting condition here is diffuse light field, transmitted light. Then it is heated sapphire from Sri Lanka. The yellow core, you can see some yellow color, little yellowish glow of the Sri Lankan sapphire. Fluorescence is orange. The yellow flow, look at this yellow flow, it is fluorescence as orange. This side you can see the orange. When illuminated with a powerful fiber optic light, it gives the evidence it is heat treated. Here, that enhancement is heat treatment, Sri Lanka sapphire. Lighting condition here is fiber optic oblique. Look at the inclusions here. See, heat altered snowballs are there. Snowballs like inclusions are here. Heat altered snowballs like crystals in a heat treated sapphire from Sri Lanka. You can identify directly. Please subscribe, give a like and share. What is here? The lighting condition here is fiber optic oblique. It is Sri Lanka sapphire, heated sapphire. Heat altered fingerprint you can see here. But when you see the fingerprint, you can see directly at once you can see it is heat altered. See, thoroughly altered this inclusion. So it is heat treated inclusion. What is it here? The lighting condition here is fiber optic transmitted. It also heated sapphire from Sri Lanka. Look at the negative crystals here. Inside the fingerprint, these are the negative crystals. When the fingerprint is heated, the tiny negative crystals that make up the fingerprint explode, creating tiny micro cracks to release the pressure. This often results in a slightly frosty appearance, as one can see here. Frosty appearance. So we can identify this as heated inclusions. What is this here? Fiber optic transmitted light is the lighting condition. It is heated Sri Lankan sapphire. Look at the inclusions. We can find it here. What are those? Bubble. There are bubbles. Melted crystals of heat treated sapphire from Sri Lanka. Bubble melted crystals. So it is heated. Next, part 7. That means capital L space 78. Lesson number 78. That means part 7. We are meeting on next heated inclusions part 7. Then please subscribe this and give a like and share to all. We are meeting on next part.